In this pod, we'll look at how you investigate how the amount of infrared radiation that is emitted or absorbed depends upon the nature of the surface. Before we start, let's revise how thermal energy is transferred. Thermal energy will move from a region of high temperature to a region of low temperature. There are three methods of thermal energy transfer: conduction, convection, and radiation.
Conduction is thermal energy transfer in solids. The particles in solids are closely packed and cannot move around. When they gain energy, they vibrate more vigorously. They pass on the vibrations to their neighbouring particles, and so the energy is passed through the solid.
Convection occurs in liquids and gases, that is, in fluids. In fluids, the particles are free to move around. When they gain energy, the particles move around faster, so they get further apart, which results in them occupying more space. The hot part of the fluid becomes less dense and rises. The space that is left is filled by colder, denser fluid. This is energy transfer by convection.
Radiation is energy transfer by infrared waves. All objects above absolute zero in temperature will emit infrared waves. If an object is hotter than the surroundings, it will emit more infrared waves than it absorbs, so it loses energy and its temperature will decrease.
For the first investigation, we will compare whether black or white-colored surfaces are better at emitting infrared radiation. You will need two identically sized containers. One container should have a shiny white surface on the outside, and one should have a matte black surface. You also need two lids, so that you can minimize energy losses by convection. Using a kettle, equal volumes of hot water just below boiling point are put into the containers. Be careful with hot water. Using the thermometers, the temperature of the water in each container is read every minute and recorded in a table. Use the first column to enter the time of each reading. Enter the temperature readings for each container into the appropriate columns. A graph of temperature against time can now be plotted for the two containers on the same set of axes. The temperature of the water in both containers is decreasing. We can see that the cooling curve for the black can is much steeper. This shows that it has a higher rate of decrease in temperature, so is losing thermal energy faster. The black container is emitting infrared radiation at a faster rate than the white container. This is because the black surface is better at emitting infrared radiation than the white surface.
In a second investigation, we will compare whether black or white-coloured surfaces are better at absorbing infrared radiation. This time, use the same two containers, one black and one white. Fill them with equal amounts of cold water at the same temperature, or do not add water, so they just contain air at room temperature. The two containers should be placed at equal distances from a heating element that emits infrared radiation. Make sure that everything is safely arranged before switching the heater on. Record the temperature inside the containers every minute for 20 minutes. Plot graphs of temperature against time for the two containers on the same set of axes. This time, the temperature inside both containers is increasing as they absorb infrared radiation from the heater. You can see that the earlier part of the graph for the black container is steeper because its temperature is rising at a faster rate. This is because the black surface absorbs infrared better than the white surface. In conclusion, matte black or dark surfaces emit and absorb infrared better than shiny white surfaces.
Examples of this are all around us. Dark clothes absorb infrared on sunny days during the summer, making us hotter, and white clothes keep us cool because they do not absorb infrared as easily. On a cold day in the winter, dark clothes radiate infrared from our bodies, making us colder, and white clothes do not emit infrared as quickly, keeping us warmer.
We make good use of this in many ways. Examples are found in house insulation, where a light silver layer is used inside the walls, and in vacuum flasks, where there is a similar silver layer on the outer side of the flask. These shiny silver surfaces prevent loss of thermal energy by emission of infrared. There are also many examples of this in nature. Polar bears and Arctic foxes are white, so as not to radiate infrared and lose thermal energy from their bodies in a cold environment. The fur of a stoat changes to white in the winter months for the same reason. Why not look around and make a list of how many examples you can find?